Good morning, fourth grade, and happy Friday. This is our third day going through this remote learning at home, and I hope that all of you are doing well in being able to get through the homework and the concepts. Remember, for those of you who are listening, and everyone should be listening, that I'm going to pronounce the secret word throughout this video, so be prepared and make sure you write that down on your independent practice. Since this is Friday, we will not have homework, but you will be required to do the independent practice. I will give you the entire weekend to submit that, and so the due date for this independent practice will not be due until Monday morning at 8 a.m. If you have any questions, make sure you reach out and ask me so that I can help you go over whatever problems you're having, whether it be through submitting work or scanning or any of the math problems that we're dealing with. I've also noticed that some of you are not scanning both pages of your homework, and therefore I'm only getting one of the pages. I'm not taking off any credit this week because of the fact that this is all new to us, but starting on Monday, I need you guys to have this down. So make sure that you do that this weekend by working on submitting your work correctly. And if you've submitted something wrong and I've written on your paper in Schoology that it's done incorrectly, I need you to resubmit a correct version of that so that you can continue practicing how to submit your work. Okay, so today we're going to be going over multiplying fractions again. Today I'm going to show you a model of what multiplying fractions actually looks like. So let's start off with this fraction 1/3 times 1/4. 1/3 times 1/4 is the same as saying that I want to know what is 1/3 of 1/4. This is also similar to when we did whole numbers, when you were saying what is 12 of 1/3 or 1/2 of 12. So if I want to know what 1/2 of 12 is, then it's basically saying what is 1/2 of the number 12, and we know that very simply as being 6. But when you have fractions here that you want to know a fraction of a fraction, you can't just simply think about a whole number being divided in half. You're looking at taking a third of 1/4 of something. So here is a picture to help you. The first fraction, 1/3, represents a square. Well, that was more of a rectangle, so let's see if I can make that better. A square that is divided into 3 parts. And that means that each one of these parts is equal to 1/3. And then I want to learn to see what is 1/4. I need to have a square that is divided into 4 parts. And each one of these is represented as 4 parts. In math, this is considered rows and this is considered columns. Oh, I was going to write that going down, but that wasn't working out for me. Whoops. Sorry. These are considered the columns. Each one going down. Now, if I take both of these pictures and put them together, I'm going to get 3 rows and 4 columns in the same picture. So, what happens here is that how many total parts have I made in this particular picture? If you count them, I have made 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What do you think that 12 would represent? That's right, 12 represents the denominator. Remember, the denominator is the total amount of parts that we have. Now, I want to determine how much I'm going to shade. Well, how much I'm going to shade depends on what the numerators are multiplied as. So if 1 times 1 is just 1, that means I'm going to be shading in 1/3 and 1/4, so 1 part for each. So the rows are getting 1 and the columns are getting 1, and when you add them together like this, they just come into one of those parts. So my numerator is going to be 1. Now if you notice that when I multiply this fraction up here, 1 times 1 is 1, and 3 times 4 is 12. So I get the same fraction. All right, let's try understanding a little bit more about what the numerator and the denominator is doing in this problem or in math altogether. So if I took a rectangle, a square, and I had 3 columns and 3 rows, how many total parts would I have? I would have 9. That is correct. And if I wanted to take the fractions 1/3 times 1/3, how many total parts would I shade? Well, since 1 and 1 of the 1/3 and of the rows and 1 of the columns together would give me this 1 part right here. So what does the numerator tell us about this problem? So the numerator tells me the total number of shaded sections. And that's why it is 1, right? Because 1 times 1 is 1. So the total number of shaded sections is what we refer to as the, let me put it in a different spot, as the numerator. And then you have the denominator, which represents the total number of sections. So the total number, sorry, my cursive went bad there. The total number of sections. And that represents the 9 because there are 9 total sections. So this is kind of like understanding the difference between the numerator and denominator and what the numerator and the denominator are doing. All right, let's draw a picture here again to show what an array is. So an array is defined as an arrangement of objects, pictures, or numbers in columns and rows. Now remember, and we have rows that go this direction and columns go this direction, or rows go horizontally and columns go vertically. So it is important to remember the difference between what the rows do and what the columns do, because that's what's going to help us understand more about our array. So in this array, we're going to be taking tiles. So if we were in the classroom, I would give you some yellow tiles, some blue tiles, and some red tiles. But for here, I'm just going to draw them as circles in their different colors. So let's take the fraction 2/5 times 2/3. And let's draw an array to represent this. So to draw the array, we are going to take the denominators and create an array with that. So the first number in my array, oh, I have to do it in yellow because that's my first color. I'm going to take the yellow color, and 5 and 3 are my numbers that I'm going to create. So I'm going to create a 5 by 3 or a 5 times 3 array. 5 is going to represent the rows, and 3 is going to represent the columns. Oops, I forgot the N. All right, now you have 1, 2, 3, 4, 5 in the rows, and then 1, 2, 3 columns. And then all you do is just fill in the other parts until you have a rectangle or square shape. So what we're going to do is we're going to determine how this fraction 2/5 times 2/3, or learning about 2/5 of 2/3, would look like in this picture. So let's take blue, and we're going to cover 2/3 of the array blue. So what does this 2/3 tell me? It tells me that I'm going to take 2 out of the 3 columns. So, whoops, sorry for that. I don't know how that happened. So 2 out of the 3 columns is 1, 2, 3 columns. So I'm going to color in very, not perfectly, but pretend I laid over another tile, blue tile over those yellows. This would represent 2/3 of this particular array. Now I'm going to take the fraction 2/5 and I'm going to cover 2/5 of the array with red. So 2/5 represents the rows. So this is the rows. And so I'm only looking at 2/5 of the rows, and therefore I only need to have 2 rows that I'm going to completely cover. So I'm going to cover this one with red and this one with red and this one with red, and keep going until I have 2 complete rows filled in. So just to kind of review, that 2/3 represents the 2 columns because there are only 3 of them, and the denominator, remember, makes the group, so there are 3 groups here. And then the rows are represented by, there are 5 of those rows, 1, 2, 3, 4, 5, and I'm only going to shade in 2 of those because my numerator determines that only 2 rows get shaded. So how can I use this to determine what is 2/5 of 2/3 or 2 times 3? I can use this by looking at my picture here and seeing which part of this, actually I'll do this in red, which part of this is covered in both red and blue and yellow. And the part that is covered in both red and blue and yellow is this section right in here. So how many total parts did my array, how many total pieces, how many total tiles did I create this array out of? It was 15. That is my denominator. And how many of those have a red, a blue, and a yellow in them? Well, I count 1, 2, 3, 4, and that is my numerator. So 2/5 times 2/3 is equal to 4/15. Is this simplified? It is, because there's nothing that goes into 4 and 15 together. Now, if you need some more practice on how to model fractions, you may work on the hands-on section in lesson 5 and the try it also in lesson 5, and I will project the answers for those pages for you so that you have them. But your assignment for the independent practice is going to be to actually practice the multiplication of fractions. So as I go through this, I'm just going to show you the steps of how to multiply fractions, since we've already went over the pictures of the fractions themselves. So in example 1, Franco ate some pizza. 2/3 of the pizza is left. Dineria ate 3/4 of the leftover pizza. How much of the whole pizza did Dineria eat? So the key words here that we see is that we have some pizza, which is the unknown. There are 2/3 that is left, and how much she ate of the leftover pizza. So we're looking at to solve how much pizza did she actually eat. So we need to find 3/4 of 2/3 because there were 3/4 left over, and she, nope, I'm sorry about that. There was 2/3 left, and she ate 3/4 of what was left. That's why we know we are multiplying these fractions. So one way and the other way. So one way is to multiply the fractions just by multiplying them across. 3 times 2 equals 6, and multiplying the denominators, 4 times 3 equals 12. This is going to give me a fraction that I have to simplify because 6 and 12 both have the same multiple, which is 6, right here, that I can divide by and get 1/2. So another way here is that we can actually simplify inside this fraction first. Now, if this second way confuses you, just stick with this way right here. But this way is actually going to make one less step in a way by canceling out anything that is similar that can be divided by the numerator and the denominator. This is called cross-canceling, where you have a fraction that if you have, like, say 3 and 3, both of them are divisible by 3, and so I can cancel them out and make them the answer of what 3 by 3 divided by 3 is, which is 1. The second thing I can do is I can also see that 2 and 4 also have a similar multiple, which is 2. And if I divide 2 by 2, I get 1. And if I divide 4 by 2, I get 2. Now, when I multiply my fractions, I'm going to get 1 times 1, which is 1, and 2 times 1, which is 2, and I will get the same answer here. Again, if this cross multiplying or cross canceling, sorry, not cross multiplying, that's something different, but if this cross canceling does not make sense to you, or if it's too difficult, do not do it. Just do it the original way here. Multiply the numerators, multiply the denominators, and then simplify. All right, you are going to work on the independent practice for lesson. This is lesson 6. We're going to skip lesson 5 because that's just drawing pictures. Your secret word is sky, like the sky that you see outside. So make sure you write that at the top of your independent practice when you submit it. And again, you can work on this all weekend. If you have questions or problems, let me know. But you are going to be doing the whole independent practice, meaning both sides, page 741 and 742. I'm not going to worry about this second example. If you want to go through the second example, I can spend some time on talking with you over it, or maybe doing some kind of Zoom lesson if you still need more help, okay? I hope you guys are all doing well. Let's see how this goes, and all the best. Enjoy, and have a fabulous weekend. Till Monday.